All right, let's talk about the learning target that states for ionically bonded substances, I can identify the charge of an ion. A particular element will form during ionic bonding and write the symbol of the resulting ion. Okay, so again, ions are atoms that have a charge, and that comes from gaining or losing electrons. But why does an atom want to do that anyways? Well, all atoms want to have a full shell of electrons, and outer shell is really what that means. Most of the time that means 8 electrons, but for smaller atoms that means just 2 electrons. They want to have the electron configurations of the noble gases. That's why this is called noble gas envy. So metals love to lose electrons to form a positive ion called a cation. And the reason why is because if they lose electrons, it's a lot faster for them to become like a noble gas than it is if they gain electrons, because metals are on the left side, as we know. So if they lose a couple, they'll already kind of jump back to the noble gases. So this is a neutral lithium atom pictured here. How many protons does it have? So the red ones are the protons. There are 3. Neutrons are the blue ones. There are 4. And there are 3 electrons. To determine the overall charge, we just pay attention to the protons and the electrons. Positive 3 and negative 3 cancels out, leaving a 0 charge. But a lithium ion is a little bit different. Notice it lost its outer shell electron, so now it's going to be like helium with just 2 outer shell electrons, just like it wants. And so this has 3 protons still has 4 neutrons, but now it only has 2 negative electrons. So the overall charge of positive 3 and minus 2 is a positive 1. So the ion symbol is Li plus 1. And we can just write a plus, since if there's just one of it, it's obvious that it's just 1. So nonmetals do the opposite. They're really on the far right of the periodic table, so it's easier for them to gain electrons and form anions to be like the noble gases. So fluorine has 1, 2, 3, 4, 5, 6, positive 9 protons. Neutrons, it has 10 blue dots. And electrons, when it's neutral, there are 9 negatives. So positive 9 and negative 9 cancel out and make 0. But let's look at the ion. There are still 9 positives, still 10 neutrons, but now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negative electrons. So the negatives are winning by 1. That means the ion symbol is F minus. So an ionic bond is when a metal ion gives its electron or electrons to a nonmetal ion, and the resulting positive and negative charges hold the atoms together. So here we see lithium giving its electron to fluorine. Lithium has that positive 1, fluorine has that negative 1, and now they have formed an ionic bond. The big picture here is that an atom tends to lose or gain electrons so that it will have the same electron configuration as the noble gas closest to it on the periodic table. This trend works for the main group elements on the periodic table, not the transition metals. Those play their own game. There is a pattern for what charge will form on an atom, making it an ion, for the main groups. So group 1A here, you can see they all form a +1 charge, because if lithium loses 1, it'll be like helium. If sodium loses one, it'll be like neon. If potassium loses one, it'll be like argon, and so on and so forth. For group 2A, they have to lose 2 electrons to be like those noble gases. So if you lose 2 negatives, you're going to have a positive 2 charge. Group 3A forms a positive 3. And group 4A is interesting. It's equal distant for them to either gain 4 or lose 4 electrons. Let's look at carbon. If carbon loses 4, 6 minus 4 is 2. But if it gains 4, 6 plus 4 is neon. So it can go either way. Group 5A, they like to gain 3. 6A, they like to gain 2. Group 7A, they like to gain 1. And group 8A is the noble gases, so they don't do anything. They just are perfect the way they are. So you can see all of these charges listed above. As a reminder, cation is a positive charge and anion is a negative charge. Another thing to know, monatomic ions are a single atom with a charge, like Li plus and F minus. And polyatomic ions are groups of atoms that are covalently bonded together, and they act as a single particle. These are the 6 that I'm asking you to study for the quiz on block day. Practice makes perfect. It says, in the next activity, you'll determine the ion that an atom will form and draw arrows showing the atom gaining electrons or losing electrons as needed. Complete the table for the resulting ion. The first 2 are done for you. So these 2 are done, although it didn't draw arrows. Magnesium wants to lose its 2 outer shell electrons. So it's got 12 protons, 12 neutrons, 12 electrons at first, but after it loses these 2 in the outer shell, it will only have 10. So then it's got 12 positives and 10 negatives. The positives are winning by 2. And so the ion symbol is Mg2+. Here's another one. This element has 7 protons, it's nitrogen, 7 neutrons, 7 electrons, but it wants to gain 3 more so that it has 8 in its outermost shell. So if it has 7 positives and 10 negatives, the negatives are winning by 3, and it will have a -3 charge. So let's do the practice ones. Here we've got 1, 2, 3, 4, 5, 6, 7, 8 positives, 8 blue circles, and 8 electrons since it's neutral. And it's got 1, 2, 3, 4, 5, 6. It needs 2 more to have the great 8. And if oxygen gains 2 more, it will be like neon. So we've got 8 positives and 10 negatives. That means the negatives are winning by 2, and the symbol would be O2-. We can double check our work because here's O, and it's under the -2. Next, we've got 4 positives, 5 blue neutrons, and this also has 4 electrons when it's neutral. It would like to lose these 2 to only have 2 like helium. So then it's only going to have 2. So if it has 4 positives and only 2 negatives, the charge will be +2. This will be Be with a +2 charge. Okay, we've got another 2 here. This one's got 15 positive protons, 16 neutrons. It's got 15 electrons when it's neutral. And since it's got 1, 2, 3, 4, 5 in its outermost shell, it wants to gain 3 more. And so it will have 18 in its outer shell. And the overall charge, if you've got 15 positives and 18 negatives, you'll have a -3 charge. And so the symbol is P, because P is number 15, P3 minus. Next, we've got 13 positive protons, 14 neutrons, 13 electrons if it's neutral, 3 in its outer shell, so it wants to lose those 3, so then its outermost shell will have 8. So if you have 13 positives and only 10 negatives, the positives are winning by 3. Number 13 is aluminum, so we would have Al plus 3. For these last two, it says you draw the picture and complete the table. So here we've got 5 positive protons, 6 neutrons. First shell has 2 electrons. Second shell has 3 electrons. And how many electrons after the ion forms? Well, when it loses those 3, it's only going to have 2 left. And this is 5 positive, 2 negative. So positive 3 charge. So number 5 is boron with a positive 3 charge. Next, we've got 17 protons, 18 neutrons, and first shell 2 electrons, second shell 8 electrons, last shell 7 electrons. This wants to gain 1 more, so it'll have 8. So then it would have 18. 17 positives, 18 negatives. This would have a -1 charge. And the ion symbol would be Cl with a -1 charge. So there you go. It's also an optional reading to kind of help understand in a different way if you would like.